An inverse function is a reverse mapping of the original function. It is written as f minus 1, brackets, x. If f of x is 2x plus 1, the mapping is, first multiply by 2, and then add 1. So the reverse mapping should be, first subtract 1, and then divide by 2. Therefore, f inverse of x is x minus 1 over 2. Domain and range are reversed in f inverse. Domain of f is range of f inverse. Range of f is domain of f inverse. Steps to find the inverse are: first, let y equal the function expression and swap x and y in it. Second, express y in terms of x. For example, f of x is 2x plus 1. First, let y equal 2x plus 1, swap x and y and make it x equals 2y plus 1. Second, move terms around to express y in terms of x. Y equals x minus 1 over 2. So f inverse is x minus 1 over 2. Let's look at a couple more examples of how to find the inverse function. F of x is 1 over x plus 1. First, we let y equal 1 over x plus 1. Then, swap x and y, and get x equals 1 over y plus 1. Multiply y plus 1 over, we get x times y plus 1 equals 1. So y plus 1 is 1 over x. Therefore, y is 1 over x minus 1. This is 1 minus x over x. So f inverse is 1 minus x over x. F of x is 3x minus 4. Let y equal 3x minus 4. Swap x and y, and we x equals 3y minus 4. So y is x plus 4 over 3. Therefore, f inverse is x plus 4 over 3. From the previous examples, we know when f of x is 3x minus 4, f inverse of x is x plus 4 over 3. Let's sketch the graph of both in the same diagram. We can see that the two graphs are reflections of each other in the line y equals x. In general, the graphs of a function and its inverse are reflections of each other in the line y equals x. This is because a point x, y in the original function becomes y, x in the inverse. If a question asks you to sketch the graphs of a function and its inverse in the same diagram, remember to make clear their relationship. Quadratic functions are many-to-one functions. So the inverse will be one-to-many, and not a function. What can we do to make a quadratic function one-to-one so that it can have an inverse? We can limit the domain to make it one-to-one. For example, f of x is 2x squared plus 4x plus 7. Let's sketch its graph. The line of symmetry is minus b over 2a. So it is x equals minus 1. If we limit the domain to x less than or equal to minus 1, only the half on the left of the line of symmetry is kept. This becomes a one-to-one mapping. If we limit the domain to x greater than or equal to minus 1, only the half on the right of the line of symmetry is kept. This is also a one-to-one mapping. If we move x up from minus 1, it's also a one-to-one mapping. This is when x is greater than or equal to 0. This is when x is greater than or equal to 1. We can see that the function is one-to-one as long as x doesn't cross the line of symmetry. Sometimes, you'll see a question asking f is one-to-one if x is greater than or equal to a. What's the smallest number of a? We know x can't cross the line of symmetry, so a min is minus 1. Now let's find f inverse when x is less than or equal to minus 1. We do this by completing the square. Let y equal f of x. By completing the square, we get y equals 2 times x plus 1 squared plus 5. Swap x and y. We get x equals 2 times y plus 1 squared plus 5. So y plus 1 squared is x minus 5 over 2. We know the domain of f is x less than or equal to minus 1. So in f inverse, y is less than or equal to minus 1. Therefore, y plus 1 is less than or equal to 0. So when we square root both sides, we add the negative sign. This is y plus 1 is minus root x minus 5 over 2. So f inverse is -1 minus root x minus 5 over 2. Remember to also write the domain. The domain of f inverse is the range of f. So it is x greater than or equal to 5. In this class, we learned f inverse is a reverse mapping of f. Domain of f is range of f inverse, and range of f is domain of f inverse. Graphs of f and f inverse are reflections of each other in the line y equals x. Steps to find inverse: let y equal f of x. Swap x and y. Express y in terms of x. Only one-to-one functions have an inverse. Limit the domain for a many-to-one function to have an inverse. Find the inverse of a quadratic function by completing the square.